Okay, so in this section, we're going to simplify rational expressions. And there are two steps that you need to do to simplify rational expressions. The first one is to completely factor the numerator and the denominator of the rational expression. So you're going to factor numerator and denominator. Then you're going to divide out common factors to the numerator and the denominator. So this is the same as removing a factor of 1. Okay, so you're going to factor the numerator and denominator, and then any factors that the numerator and denominator have in common, you're going to divide those out. And then you're going to see what we mean by removing a factor of 1. Okay, so let's look at this example. This is going to be number, well, let's just say this example. Simplify. Number 1, we have 3, that's a 3, divided by 9x plus 6. Okay, so 3 divided by 9x plus 6. Now, the numerator is a monomial. That's just a 3. The denominator is a polynomial. Well, the numerator is a polynomial as well. So remember, a polynomial is a one or more monomials. But in this polynomial here, those two terms, 9x and 6, they have a 3 in common. So when you simplify rational expressions, you want to first of all factor the numerator and then factor the denominator. So when I factor the denominator, I'm going to get 3 times 3x plus 2. All right, so that's where I'm at. So that was the first step. So the first step, remember, is to completely factor the numerator and the denominator of the rational expression. All right, so then the second step is where we divide out common factors, or we reduce. So if you look at this factor, now let's talk about factors. This is a factor of the numerator, and my denominator, this is a factor, and this is a factor. So you have 3 factors all together. So if you look at the numerator and the denominator, they both have factors of 3. So remember, if you have 3 divided by 3, that's the same thing as saying 1 over 1, which is just 1. Remember that? So 3 and 3, they have 3 in common. So what you did 2 semesters ago was that you said, well, they're both divisible by 3, so 3 divided by 3 is 1, 3 divided by 3 is 1, and so that's where we get this 1 over 1. See, 1 divided by 1. But 1 divided by 1 is just 1. Okay, so we're going to do the same thing here. So these factors, they have 3's in common, so you're going to say 3 divided by 3 is 1. Make sure you put the 1 there. And then 3 divided by 3 is 1. And so I get in the numerator 1. And the denominator, 1 times this binomial is just that binomial. So it's just 3x plus 2. And there's your answer. All right, so that was the first example. All right, let's look at this one. Suppose we had 9x plus 99 divided by x squared plus 11x. So 9x plus 99 divided by x squared plus 11x. All right, so again, the first step is to factor the numerator and denominator. And then the second step is divide out your common factors. So in the numerator, I can factor the numerator. So that's 9 times x plus 11. So remember, you always want to use the greatest common factor. If you don't, you're going to have to go a little bit further with it to make sure you factor completely and this thing is simplified. So you want this to be simplified, this rational expression. These are rational expressions. You want these rational expressions to be simplified. So always make sure you use the greatest common factor. In the denominator, remember, always look for a GCF first. So my GCF here is x. So I get x times x plus 11. Because x times x is x squared. X times 11 is 11x. All right, now that was the first step. The second step is to divide out common factors from the numerator and denominator. So if you look at the factors that you have, 9 is a factor, x plus 11 is a factor, x is a factor, x plus 11 is a factor. So what you may want to do is just look at the factors of the numerator and see if any of these can be reduced with anything in the denominator. So for example, I have this 9 right here. Is there anything in the denominator that occurs as a factor that will be reduced into 9, or that can be simplified with 9? And the answer is no. Okay, there's nothing in the denominator. This is an x, and this is an x plus 11. If you go to the next factor, x plus 11, is there an x plus 11 occurring as a factor in the denominator? The answer is yes, right here. So just using the same idea here, since these are the same factor, if I divide x plus 11 by x plus 11, I get 1. If I divide x plus 11 by x plus 11, I get another 1. And so I get 9 plus 1 is 9, and then x times 1 is x. So 9 times 1 is 9, x times 1 is x. And there's nothing else you can do. That's an x right here. So there's your answer. 9 divided by x is your answer. So again, factor, and then divide out your common factors. All right. Number 3, you have x minus 3 divided by x squared minus 6x plus 9. So x minus 3 divided by x squared plus 6x minus 6x plus 9. Okay, so if I factor the numerator, if you look at the numerator, there's nothing I can do there. There's no GCF. It's a linear binomial. There's nothing I can do. Now, when I say there was no GCF, I mean other than 1, there's no other GCF. So I'm going to rewrite x minus 3. Over here, remember you have a trinomial. The GCF is 1 down here, so go directly to the two binomials, just like we've been doing before. And when you factor this, at this point, you should be proficient with factoring. It's not always going to come quickly to you, but it should be quicker to you than you did when you first started factoring. But when I factor this, that's going to be x minus 3 times x minus 3. So that's what I get. All right. Now, look at your factors. I have x minus 3 occurring as a factor up here. I have an x minus 3 occurring as a factor here, and x minus 3 occurring as a factor here. So let's see if we can reduce. I have an x minus 3 as a factor. Think of these as factors. X minus 3 is a factor. Is there an x minus 3 occurring as a factor down here? The answer is yes. In fact, there are 2 of them. But I can only reduce 1 at a time. So this is 1, and this is 1. So when I divide x minus 3 into x minus 3, I get 1. When I divide x minus 3 into x minus 3, I get 1. And so that's about all I can do. So the answer will be 1. The numerator is 1. And 1 times x minus 3 is x minus 3. All right, so that's the answer there. Okay, let's look at this one. Number 4. You have 12x squared plus 4x minus 1 divided by 2x plus 1. So 12x squared plus 4x minus 1 divided by 2x plus 1. Okay, so the numerator is a trinomial. So let's factor this as 2 binomials. The GCF is 1. My denominator, I can't do anything with that. The GCF is 1. It's a linear binomial. I can't factor that. So I'm going to leave it as 2x plus 1. Now let's talk about the numerator. Let's see, you may have to do some work to figure this out, but let's try 6x and 2x, because 6x times 2x is 12x squared. The last line, or the last term is a negative 1, so I know that these signs are going to be different since the last term is negative. And the only possibilities for the absolute value of negative 1 is 1. The only possibilities for 1 is 1 and 1. And if you look at the outer is going to be 6x, the inner is going to be 2x, and since the signs are different, I'm going to subtract those, and I'm going to get 4x. So far I'm good. And I want the larger of those to be a positive. So that means that this has to be a plus sign, and this has to be a negative sign. Okay, now, as you go along, a little trick, and it doesn't always work, does not always work, but a little trick is this. If this is a 2x plus 1 and you had put a 2x minus 1, something should have told you something was wrong, because usually you're going to reduce. Not always, but usually you're going to reduce. So if that's the only factor down there, then it's probably going to reduce with something up here. So this should have been 2x plus 1. All right, and then you reduce. Well, 2x plus 1, they both have a 2x plus 1 in common. So 2x plus 1 divided by 2x plus 1 is 1. 2x plus 1 divided by 2x plus 1 is 1. And I'm left with 6x minus 1 divided by 1. Times 1, which is 6x minus 1. Let me just go ahead and rewrite it over this 1, but that's just 6x minus 1. So there's your answer. All right, so that was number 4. All right, the next one. All right, so let's suppose we had this. Suppose we had x to the 4th minus 10x cubed divided by x squared minus 17x plus 70. So x to the 4th minus 10x cubed divided by x squared minus 17x plus 70. All right, in the numerator, I can take out an x cubed. So I'm going to get x cubed. Remember, always use the GCF. X cubed times x minus 10, because x cubed times x is x to the 4th. X cubed times a negative 10 is a negative 10x cubed. All right, divided by, now the GCF in the denominator is 1. So we'll go directly to 2 binomials. Now let's think about what we said. See how this is an x minus 10? You may have an x minus 10 down there. Let's see. So over here, when I factor this trial and error, I get x and x. For 70, the possibilities are 7 and 10, 5 and whatever. Let's see, what's 70 divided by 5? That's going to be 14. So you get a bunch of things for 70, but look at what you have here. You have a 10. See this x minus 10? So see if 10 times 7 is going to work. So put 10 here, 7 here, and see if it works. All right. Now remember, the last sign is positive, right? So that means these signs are going to be the same, and they're going to be negative. Remember all that stuff you learned from the previous chapter. So if you look at this, this is what you needed. You needed that x minus 10 because the outer is a negative 7x, the inner is a negative 10x, and when you add them up, you get that negative 17x. So that's what you wanted. So always look for something like that. It may help you. Doesn't always, but it will at times. And then you reduce your common factors. You divide out your common factors. You see right here that x occurs as a factor 3 times. So x is a factor. All right. So your factors are x. It occurs 3 times. Your other factor is x minus 10 up here. You have an x minus 10 occurring as a factor down here, and you have x minus 7 occurs as a factor down here. So if you look at the first factor, remember we said x is a factor. Do you have any x's as factors down there? You should have said no, because the only factors down here is x minus 10, x minus 7. There's no other x by itself. Okay? Now look at x minus 10. X minus 10 occurs as a factor down here. Do you see it anywhere down there? The answer is yes. So when I divide these, you remember this, x minus 10 divided by x minus 10 is 1. Anything divided by itself is 1. So basically what you're going to do is you're going to say that's a 1, that's a 1. So when you divide them out, x minus 10 divided by x minus 10 is 1. X minus 10 divided by x minus 10 is 1. And so finally you have x cubed times 1 is x cubed. 1 times x minus 7 is just x minus 7. And there's your answer. All right, so you get x cubed divided by x minus 7. All right, number 6. Let's see. You have 5x squared minus 500 divided by 35x plus 350. All right. So when you factor the numerator, see there's a 5 as a GCF, so do that first. So I get 5 times x squared minus 100, all right, divided by, here I can factor out a 35. Always use the GCF. GCF here is 35. I get 35 times x plus 10. All right, so that's where I'm at. Now, be a little bit careful. You got to make sure you factor completely. See this x squared minus 100? You can go further with that. That's the difference of 2 squares. So I'm going to get 5 times x minus 10 times x plus 10. So you must always factor completely. Use everything you've learned from the previous chapter. So this right here is the difference of 2 squares. So that's over 35 times x plus 10. All right. All right, so that's where we're at. So I factored completely. That was the first step. The second step is to reduce, to divide out common factors. All right, so look at the coefficients. So you see this is a 5 and this is a 35. 5 and 35, they have a 5 in common. But always try and use the greatest common factor, and the greatest common factor is 5. They also have a 1 in common, but the greatest common factor is 5. So you're going to say this. You're going to say 5 divided by 5 is 1. 5 divided into 35, or 35 divided by 5 is 7. So that's where I get 1 over 7. And it kind of makes sense because in a previous course where you were asked to reduce this fraction, you said that was 1 over 7. Because 5 goes into 5 one time, 5 goes into 35 7 times. And that's where see this 1 over 7? So that's where that comes from. Now the next one is x minus 10. Is there an x minus 10 in the denominator? The answer is no. The next factor is x plus 10. Is there an x plus 10 in the denominator? The answer is yes. So I can reduce those. That's going to be a 1, and that's going to be a 1. And that's all you can do. So the answer then is going to be, look at this. It's 1 times x minus 10 times 1, which is x minus 10, over 7 times 1 is 7. So there's your answer. All right. Let's look at this one. Okay, so we have 8x cubed minus 27. 8x cubed minus 27 divided by 4x squared plus 6x plus 9. So 8x cubed minus 27 divided by 4x squared plus 6x plus 9. All right, so over here, this is the difference of two cubes. So if you need to remember how to do that, just kind of fill in these parentheses just like we did before. So this is the difference of two cubes because 8x cubed is 2x to the third power. 2x times 2x times 2x is 8x cubed. 27 is 3 to the third power. So 3 times 3 times 3 is 27. And so this is your f. Remember how we talked about f and L? So I can factor this as f minus L times f squared plus fl plus L squared. So that's how we factor this. So let's go ahead and see what this is. So that's going to be f minus L, so that's 2x minus 3. So 2x minus 3 times, all right, remember, you got to do some things on the side here. If you do too much in your head, you may mess up. So f squared, remember, f squared means f times f. And so f here is 2x. So 2x times 2x is 4x squared. So that goes here, 4x squared, plus f times L. F times L, remember, is this is 2x times 3. So 2x times 3, which is 6x. So plus 6x. And L squared means L times L. L squared means L times L. L is 3. 3 times 3 is 9. All right, so that's how you factor the numerator. So the numerator here is just this. So we write this as 2x minus 3 times 4x squared plus 6x plus 9 divided by, all right, now let's factor the denominator. Now remember we said a while ago, remember this is a trinomial, quadratic trinomial. So remember we said a while ago in some previous examples, see, chances are you're going to want something to reduce. It doesn't always work, but most of the time it will. So if this is a binomial factor, then chances are I may have a 2x minus 3 in here as well. So when I factor this, I may need a 2x minus 3. All right, so let's see what happens. Let's see, let me make sure I wrote down the problem correctly. Okay, all right, so let's see what we get. We're going to get 2x times 2x is 4x squared. The outer is 3. The outer is 3. Okay, so the outer's The outer is 9. I'm sorry. The outer here, so I need 3 and 3. But that's not going to work because when I do 3 and 3 here, I'm going to get 6x and 6x, which is 12x. So that's not going to work. So let's see. Let me go off to the side and kind of do the work there. So 4x squared plus 6x plus 9. 2x, 2x. 9 and 1 won't work. Okay, so that's not going to work. So what that means is this. You see how I was trying to factor this and it didn't work here? So that means, and even if you try 4x and x, and you put, let's say, 3 and 3, that won't work either if you did the outer and inner. Now, so that means that this right here, I can't factor. Now, before we go on, I want you to think about this. You see how you see this 4x squared plus 6x plus 9? You remember we talked about in a previous lesson that when you factor the difference of two cubes, and you first of all took out the GCF, and you factored this trinomial cannot be factored. So right here, I should not have spent my time going through that, but that's what many of you are going to do. So you go through the process, you're going to notice that doesn't factor. But this right here is this. So you knew right away it could not have been factored. So I'm going to go ahead and just rewrite it. Just rewrite it. And now you look at your factors. My factors here is 2x minus 3. The factor here is 4x squared plus 6x plus 9. And that occurs right here. So basically, you're going to reduce them out like this, divide them out. And all you're left with is 2x minus 3 times 1 over 1, which is 2x minus 3. All right, so that one was a little bit, if you weren't careful, and at first I wasn't paying attention to this, but if you're not careful, you'll be wasting your time trying to factor when your denominator is exactly this. Okay? All right, so that's going to be part 1. I'm going to change this to simplify rational expressions part 1. So we're going to do a part 2 in the next lesson.